Hello everyone, let us go to the second problem. You are on a rollerblades on top of a small hill. Your potential energy is 1000 joules. The last time you checked, your mass was 60 kilograms. Now, what is your weight in newtons? What is the height of the hill? And as you start skating down this hill, your potential energy will be converted into kinetic energy. At the bottom of the hill, your kinetic energy will be equal to your potential energy at the top. What will be the speed at the bottom of the hill? Okay, so the first thing that we need to do in looking for the unknown values is to look first for the following given in the problem. So the given are, we have the GPE or the gravitational potential energy, which is 1000 joules. And then we have your mass, which is 60 kilograms. And even though a gravitational acceleration is not mentioned, still we are going to use it. So we have here 9.8 meters per second squared. So the first thing that we need to look for is your weight in newtons. So to get the value of weight, we have W is equal to mg. So we have here 60 kilograms times 9.8 meters per second squared. This is equal to 588 kilograms meters per second squared, or 588 newtons. Okay, so let's go to the calculation of the second unknown, which is the height of the hill. So in solving for the height of the hill, we are going to use our equation GPE is equal to mgh, where GPE is equal to 1000 joules equal to the mass, which is 60 kilograms, times the 9.8 meters per second squared times the variable h. So we are going to extract the unit for joules. We have 1000 newton dot meter is equal to the product of the two values. We have 588 newtons times the variable h. Divide both sides by 588 newtons and then cancel the unit. So the height is equal to 1.70 meters. Okay, now let us go to the third unknown value. What will be your speed at the bottom of the hill? So in this question, we are going to look for the relationship of the GPE and the KE. How are they related with each other? Now let us go first to the relationship of the GPE and the KE in terms of work. So we have work is equal to GPE, total. So specifically, this is referring to the net work. Also, we have network is equal to the kinetic energy total, or the maximum kinetic energy. Take note that the maximum kinetic energy and the maximum potential energy is also referred to the total kinetic energy and the total gravitational potential energy. Okay, if you're going to look at here, these two values are equal to the net work. So because of that, we can say that GPE total is equal to the KE total. Now, based on our problem, the GPE total is equal to 1000 joules. Then therefore, we can also say that the KE total is equal to 1000 joules as well. Now that we already know the K total, then we can now get the velocity or the speed at the bottom of the hill. So in getting the velocity or the speed, we are going to use our equation Ke is equal to 1 half mv squared, and then substitute the values in the equation. So Ke is equal to 1000 joules equal to 1 half times your mass, which is 60 kilograms times v squared. Okay, so we are going to expand this joules na unit. We have 1000 kilograms meter squared per second squared. Okay, so it overlapped. Well, anyway, here it is. So 60 divided 2, this is 30 kilograms times your variable v squared. Divide both sides by 30 kilograms. And then cancel these 30 kilograms. You have the variable v squared, which is left on the right side. And then cancel the units here. We have 1000 divided by 30. This is 33.33 meters squared per second squared, and square at both sides. So V is equal to 5.77 meters per second. Therefore, as you go down the hill, your speed is 5.77 meters per second. And that's all for the second problem. Thank you everybody for listening.